Assalamu alaikum. Hello everyone. I hope you all are fine. Today I am going to start the subjects of pure mathematics. Basically in pure mathematics I will first deal with calculus and then abstract algebra and then complex variables. Basically this course not only help the very basic level students but also the students that are preparing for CSS competitive examinations and for other exams. In pure mathematics, like I am dealing with calculus, so I will cover all the following topics, and also there are other ones but I have written down only 21 topics like real numbers, limits, continuity, differentiability, indefinite integration, mean value theorems, Taylor theorem, indeterminate forms, asymptotes, curve tracing, definite integrals, function of several variables, partial derivatives, maxima and minima, Jacobians, double and triple integration techniques only, and applications of beta and gamma functions, area and volumes, Riemann, Stieltjes integral and improper integral and conditions of existences, and implicit function theorem. These are all the topics that I am going to cover in my video lectures, and there are also few other topics, and I will deal all these topics one by one, and I will upload my videos inshallah. And first of all, our topic is real numbers. We denote the set of real numbers by writing this symbol r. Okay, and real numbers basically is a combination of rational numbers and irrational numbers, and then we call these numbers real numbers. Rational numbers are the numbers that can be written in a p over q form, and irrational numbers are the numbers that cannot be written in a p over q form. And irrational number, there are other types like recurring and non-terminating, and irrational numbers are the other one who continually repeat itself, but the numbers vary one by one, like square root of 2 is an irrational number. So real numbers, we can write it as this one, q union q dash means a combination of rational and irrational numbers. And real numbers can be constructed from rational numbers, but we can prove this, but the scope of this is beyond our approach. That's why I'm just writing here that rational numbers can be constructed from real numbers can be constructed from rational numbers. Now there are some axioms that real numbers prove. For example, axioms of addition and subtraction, like clear property hold. For example, if we take two real numbers and if we add them or subtract them, then we will get another real number. For example, I will take our first real number, that is you can write 4, and b is maybe you can take 2, and if we add these two numbers, then we get an if we add these two numbers, then we get another real number because it belongs to a real number, and if we subtract these two numbers, then we will get another real number. So clear property hold, commutative property hold, also associative property exists, additive identity. In case of addition or subtraction, additive identity is 0, and additive inverse exists. And also exams for multiplications hold, like clear property, if we take two real numbers, and if we multiply them together, then we get another real number. And commutative property hold, like if we multiply two real number, ab is equal to ba, means from both sides if we multiply them with each other, then we get the same answer. And associative property hold, multiplicative identity is basically 1, and multiplicative inverse of non-zero elements exist, because we cannot divide by 0, and that's why additive inverse for only non-zero elements exist, not 0. And right and left distributive laws for multiplication over addition holds. Okay, the other property of set of real numbers is that real number is the set of real numbers is a field. But we have to know that what is a field. Basically, I write here the definition of a field, that a non-empty set f under multiplication is said to be a field if the following axioms holds in f. Now I will discuss what are the axioms that have to be held in order to be a field. First of all, f means f we take a non-empty set, And f under addition, if under addition we apply on addition, is an abelian group. And here we have to know what is group. In group, first of all, clear property hold, then commutative hold, then we get an abelian group. Associativity hold, and a clear associative, and identity and inverse hold, and if also a commutative, then we will get an abelian group. I will discuss further in detail the group theory course also, but here we just have to know that what is basically a group. And I told you that first of all clear, then associative, then identity and inverse, and then if commutative property hold, then we will get an abelian group. And f minus 0 under multiplication is an also abelian group, and distributive laws hold in f, then f is said to be a field. And if we apply all these exams on the set of real numbers, then all these exams hold. That's why our set of real numbers form a field. I think it is enough for today's lecture. Then later I will discuss other properties of real numbers, and some other properties. Thank you.